standardization of scatter plots, okay? And this really is when we're talking about correlation of stuff, right? So we'll keep that in mind, correlation. So we've just kind of made up some data here. Maybe it's an island, and there's people on this island and bunnies on the island, okay? And our x values are all of our bunnies, and our y values are our people, okay? And we just happened to find, maybe we found several islands, and this seems to be the correlation on each of these islands, okay? So this is the information we found about all of this stuff, okay? This is how they correlate to. So on island number 1, we'll say, we'll call it this guy here. There happens to be 2 people and 2 bunnies on that island. Well, what we're going to have to do in order to solve this stuff is we actually have to find a standard deviation. We have to find a mean. We have to find an average. So what is the average number of bunnies on an island? What's the average number of people on an island? What are the standard deviations of those two? So we actually have to do all that process first. So we'll quickly go through that. And the way we're going to go through it, if you look, these are all our numbers for bunnies. So we have a 2, we have 2 3s, we have 2 5s, a 6, and a 7. So in order to find average or mean for bunnies, we add up all those numbers, right? So for bunnies, we'll do first down here, the mean for bunnies is equal to all of those numbers. Do you see how I got those numbers? So I had 1 2, 2 3s, so plus 3 and 3, 2 5s, a 6, and a 7. And then how many terms were there altogether? Well, there's going to be 1, 2, 3, 4, 5, 6, 7. So there's a total of 7, right? So in order to calculate this mean, we're going to have to divide that value by 7. So we'll quickly do this. That's going to give me 10, 15, 10, 29, 31 divided by 7. What does that give you?
4.42.
Perfect. The mean for bunnies is there's an average of 4.42 bunnies on every island. We'll do the same thing for people, right? Mean, we've got to add up all their values. Well, their values are measured on the y-axis. So we have 2 2s, a 3, and we have 3 5s, and a 6. So there's going to be 7 values again. So like we said, we had it's going to equal 2 plus 2 plus 3 plus 3 5s, and a 6. Do you see how I got that information?
Mm-hmm.
Okay. And then we
26.
divided by 7.
3.71.
3.71. So the average of people is a little less than bunnies. So we've got that. Those are going to be our x bar, okay, for both. Okay? Those are going to be our x bar for both. Now, in order to standardize this, what we actually have to do, and the way they've written it in your... Sure. Yeah, that's a good call. You're right. We should put y bar for the people. This should be y bar, right? Because that's measured on our y-axis. What they want us to do is find the z-scores of each of these. Okay. Well, in order to find z-scores, we have to find standard deviation. So instead of showing standard deviation on this, because we know it's a really long process, we're going to find that standard deviation, and I'm going to show you how to calculate this. So I'm just going to pause for a sec. All right, so we did a heck of a lot of calculating, okay? And we'll just quite walk through the process. We found our mean for people. We subtracted by the mean. Then we squared those values, added them all up, right? And we got this value when we added that all up. We divided by 1 less than the number of terms. So there were 7 terms. We divided by 6. We square rooted. Our standard deviation for humans is 1.66, okay? We did the same thing with bunnies. Took all of the data, and we subtracted by the mean. We then squared all those values and added them up. When we added them up, we got this. We divided that by 1 less than the number, which was 6, square rooted it, and the standard deviation for bunnies is 1.81. Okay? So a lot of work. We didn't really show it, but that's what we did. So we got it all now. Now, we're going to jump back to the first page and zoom in here. Single page display. Okay? And what we're going to do for standardization, go to 100, good. When we go to standardization, there's a formula. And the formula says we're going to make a new scatter plot. So for every point we have here, which we're probably going to want to write down each of the points, okay? And actually, I'll do that really quickly. Our first island was 2 and 2. Do you see that? This one's 2 and 2.
Mm-hmm.
The next one is what?
3 and 3.
Yeah. What else?
And 3 and 5.
Yeah.
And then 5 and 2.
Good.
And then 5 and 5.
Mm-hmm.
6 and 6.
Yep.
7 and 5.
Good. Okay. So these are all of our points right now. We're going to have to use this formula. And the formula says the z-score of x and the z-score of y. So they're going to give us new coordinates. So every coordinate, we're going to plug into this formula here to find the z-score of x and the z-score of y. These are the actual values in this graph. We're going to be creating a new graph. And the new graph will give us all of our new coordinates. Now, in order to find each of those, okay, to find a z-score, we take z-score of x, which in this case is our bunnies. We take all of our data, subtract it by the mean, and divide that by the standard deviation of bunnies, right, in this case. And we found that on the other page, the standard deviation. That's why we needed to know it. All right, so there's a lot of process just to get that info. And then the other coordinate, so that's for the x value of the new coordinate. For the y value of the new coordinate, so the z-score of our y's people are going to be all of our y data, subtract the mean of people, all divided by the standard deviation of people. So we'll go through one or two here, and then we'll actually pause again and get all the information because we don't want to go through that whole process again, right? So let's jump back in page width. I'll scroll down here. So just to recap and help you remember this, 1.66 and 1.81. Okay, so people, standard deviation of people was 1.66, right?
Okay.
And standard deviation of bunnies,
1.81.
yeah. And on top of that, we have to know the mean of people. So the y bar, right? We have to know that for our formula is 3.17. So we found that earlier. 3.71, thanks. And then the x bar of bunnies, so the mean of bunnies was 4.42. Okay, so that information is all going to come into play here. So our very first coordinate, 2 and 2, we're going to put it into our new z-score formula. Okay, so our new z-score formula, we'll do this one in purple. So z-score of x and z-score of y, so our new coordinate is going to be equal to the value, well the value is 2, minus x bar. Well, x bar is 4.22. 4.42. Does that make sense?
Mm-hmm.
All divided by, and I shouldn't have put a bracket there, sorry. What's the standard deviation of bunnies?
1.81.
Yeah, 1.81. That's going to give us our first coordinate. Our other coordinate is going to be 2 again, but subtracting the mean of people, which is 3.71, all divided by
1.66.
Good that you can see it so quickly. Great. So we're actually going to calculate this. Okay, we'll do this in our calculator here. So the first one, 2 subtract 4.42 is equal to that value divided by 1.81, negative 1.33 we'll say. Okay, so the first one is negative 1.33. That's the new x coordinate when we standardize.
Okay.
Okay, and remember the original coordinate was where? It was positive 2. We're now at negative 1.33. This is below the mean, hence why we have a negative z-score. That we know that makes sense from what we've done before. And then the same thing's going to happen here. We're going to do 2 subtract 3.71 divided by 1.66, and we're going to get negative 1.03. Negative 1.03. Okay, and that will be our new y. Now, we'll probably need a bit of a better graph from the one they have here because that's only in ones. All of our standard deviations are probably going to be within what? Remember, standard deviations really only go how far?
Negative 1 to 1?
Well, negative 1 and 1 is 68.
No, 1 to 3.
Yeah, 3, right? Negative 3 to positive 3. So we're going to make a new graph for our standardization. And this is only one coordinate, right? So far, we've only standardized this guy. This is the new coordinates for the standardized version of that point. So we'd have to do that for every single one, which we'll go through another one, and then we'll actually do the rest off air so that we don't waste too much time. So when we build our new chart, though, right? So we're going to build our graph here. Our graph needs to go, okay? It needs to go both up 3 and over 3. Yeah, that makes sense. So we really want to go up 1, 2, 3. These are going to be our our standardized y coordinates at -1, -2, and -3. And again, it can go past that, but we're assuming it probably won't. And then to the right, we're going to go over 1, 2, 3, and -1, -2, and -3. So the very first point right here was at -3, 3. That was our x. And yes, a -1.33 and -1.03. So that's probably about there. There's our first one. We'll do another one quickly, and then we'll do the rest kind of off fair. Let's do one that's a little more. There'll be a little more difference to it. Let's try this guy. Okay, we're going to do that guy there. So same formula. We're going to get a zx, a new z-score, and a new z-score for y. So that's going to give us 3 subtract, well, the mean doesn't change, 4.42, divided by the standard deviation, which is 1.81. And for the y, it's going to be 5 subtract 3.71, divided by 1.66. So we plug those in our calculators.
-0.784.
-0.78. Okay, there's our x coordinate. And our y coordinate is actually going to be a positive value. What did you get?
2.765.
When you divided it?
Oh, did I do it wrong?
Yeah, don't forget to divide it also.
5? Okay.
You're right from that part.
Okay.
Yeah, so there's our other point. So when we go to plot this one's a little different. We'll put him in green here. He's at almost -1 and almost +1, so he's about here, a little different. That's our x and our y value, okay? So let's do the entire page here. So we're going to quickly calculate the rest of these. So we've done all this information out here on the side here, if you noticed, okay? And the first one we did was a yellow. I'm going to do it in black because it doesn't show up much. The new standardization is -7.8 and -4.2. So -7.8, 4.2 is probably going to be about there. Okay, so that was this point here. Okay, we just did. The next one is +0.3 and +0.7. So +0.3 and +0.7 is maybe about there. +0.3 and -1. So +0.3 and -1-ish is about here on the standardization. +0.8 and +1.3. 0.8, 1.3 is maybe about there, and 1.4 and 0.7. 1.7. So those make sense how we standardize them?
Mm-hmm.
Okay, so let's focus in on this page now. Now that we've done all that hard work. Okay, and we're going to talk about how this way. So this was the new standardized one. So if you look, the old chart, it's a little hard to see. The old chart really only existed up here. But once we standardized everything, it exists in the positive and in the negative range, and even in some of the other quadrants, okay? So the way the pattern works, it's similar, but standardization is very different from what it was before. We have to put everything through that very long process in order to standardize something.